Hey, Rubicon Ranger here. This is going to be a video about torque and Robocraft 2 and how to use it in your designs, especially now that flying parts have been released. So we have thrusters and anti-grav blocks, so you can make flying machines, and getting them to turn can sometimes be difficult. So I've got three different torque generators here, one of which is just a classic gyroscope. And we're going to quickly talk about torque, and then I'm going to do a demo of these. I'll show you a practical application for all three of them, as well as two for a normal gyro, and then that'll be it. So torque, or a moment, which when people say a moment in engineering terms, that's a moment arm or a lever arm, is just a way of generating, torque around a point. If that's a fixed point, so this could be a hinge and this is the door. Or if it's a solid object and you have force being applied tangentially to the outside of it, it'll want to, because an object at rest wants to stay at rest unless otherwise acted upon, right? The center of mass wants to stay in place. If you put a force on the outside, it spins around the center, which is what we're going to take advantage of for flying machines. So your moment at any point is equal to the distance from the point of rotation, and that could be your center of mass, which can be a function of where your forces are applied, or it could be a fixed point, right? A hinge or a rotational pin joint. So your moment around a point is equal to the distance times the amplitude of the force acting perpendicular to your vector coming out from your center point. So basically this length times the force equals your moment, right? So if I had two thrusters pointing this direction at this distance from the center, it would be a moment of 2. If I increased their distance from the point of rotation by twice this length, it would be 4. And so on and so forth, right? And you can pick any point of reference and do that same calculation using that point of reference of rotation. So you can balance moments around any point. So how can you use this kind of thing to your advantage? Well, you can use it for turning things, especially air vehicles, or you can use it for stabilization in vehicles that have difficulty staying upright. I know some people have tried to make monowheel and bi-wheel bots that have some difficulty staying upright. We'll quickly look at just a super simple controller for that, but let's quickly go over the 3 torque generators that I've been using so far. Let's start off with this one. This is pretty old hat. This is an older, I think someone discovered this super early. Guy Horn mentioned it to me really early on. I suspect this is something that has been used even before this game split off to become Robocraft 2 officially. And it looks like FreeJam was talking about how the Havoc engine, this is more of just an artifact of the Havoc engine, physics engine that they're using. So basically what's happening here is the hinges tip this plate against this other plate, and it exerts a force here, and then I think also a force gets exerted back up here on the hinge. And technically the structure should be rigid and it should cancel all that out, and you shouldn't get any excess moments or force, but it ends up generating a moment around. So this is pointing down, this is pointing up. The mass is here, but the center of rotation, due to the excess force here, ends up being a net, kind of clockwise motion if we're looking at it from this direction, and these edges are contacting. Now the physics here are really wonky, and I think it's just artifacts of physics engine spaghetti code, but you have to use medium material for this. I've been messing around with these for a while. If you use the lighter material, or if you use the heavier material, it doesn't seem to work. So the laudium and the arium don't seem to work very well. Midornium is quite nice for both types of torque generators. This is the torque generator that I discovered. I don't know if anybody else has discovered it. It also plays by the same weird rules where it has to be made out of the medium material. There's other weird rules, like this has to be a 3x3x3 slope. I don't know why. You can't get away with a 1x2 or a 2x2. And this plate has to at least be a 1/3 thickness medium weight plate. Same thing with here. So you can replace the bottom 2/3 of this plate with arium and it will still function fine as long as the contact surface is made out of the medium material. And same thing for this. So I could replace this with, if I go back to build, I can replace it with the normal arium. I'll make this arium and then make the last one medium material, and you'll see it work just fine when we go to check these out in a second. So go to materials. So if we do that, and then finally this is a good old-fashioned gyroscope. So it's just a plate, which, by the way, if you rotate an object, the amount of torque that you'll get, or the resistance to it moving in this case, is going to be a function of the distance of the mass from the center. So I won't get into it too much, but basically think that, so the mass on the very outside of this plate is much more effective at preventing it from moving. It has a higher mass moment of inertia than material towards the inside. So this block here basically is generating nearly 2 times the amount of resistance to movement that this block would be generating, which is only 1 block from the center. So having a flat plate like this means it has a large mass moment, so you spend as little mass as possible to get as much resistance against this motor's rotation as possible. And what ends up happening here is if your plate is turning, for instance, clockwise, for every reaction there's an equal and opposite reaction, which means it's going to generate a counterclockwise moment on this arm, which is going to generate a clockwise moment about this moment arm. Hopefully that makes a little bit of sense. Basically this one spins this way, the arm spins the other way to counteract, and then it spins the original direction for this, if you take this reference point to be your center. So you'll be able to see that in just a second, but let's just give a test of all these. Alrighty. So first one is this torque generator that's just a flat plate. This one's quite nice. It's bidirectional. So I've got 2 hinges here, and they're facing opposite directions, and that's because the hinge actually behaves differently in one direction than it does in another. And there's some excess forces, and some of them end up canceling out when you have the hinges facing away from one another. So I've got them canceling one another out here. But you can see with very, very little application, it turns quite quickly. The problem with this one is that it generates a lot of excess torques that are out of plane with your usual moment, right? It can get kind of chaotic if I hold it down for a little bit. You'll see it's not quite, yeah. And if you hold it down for too long, it goes nuts. So, but just little taps seem to be good for this one if you're just gentle with it. I like this one a lot. You can get away with technically 1 hinge, but then you get more excess torque out of this. And then let's go on to the second one. We've got, oh, that's the wrong one. So this is the second torque generator, and this one I actually like a lot. Unfortunately, it's only omnidirectional. It only generates torque in one clockwise motion here, or well, clockwise in this case. And you can see it generates very clean torque, to the point where it's almost eerily consistent. And this one's really precise, and it can generate a lot of torque, but once again, it only moves one direction, and yeah. So I personally like that one, but it's expensive to use. And then finally we have our little good old-fashioned gyroscope here, and you can see like I was talking about, so if we spin the plate one way, it makes the arm spin the other way, and then it spins the same direction around the hinge which is holding it. So all that to cancel out and go to ground basically, versus where your torque's really being canceled out. Now if you're in the air, you'd probably rotate around whatever the center mass of this arm is, if you didn't have this assembly here, right? So if I have 2 of these on either end of a bot and they're rotating the same direction, it's going to rotate about the center point between the 2. So you can see that going there. And once again, this is omnidirectional, or bidirectional. The only problem with this is that, one, the motors seem to kind of glitch out. I don't know if you can see like the, rotor pieces coming through there on the motor. One, it's a little glitchy. It'll kind of like stop every now and then and just kind of like jerk and comes to a complete stop. I don't know why. And then the other downside to it is it saturates out. So you can only go so fast. They have like a speed limiter on these motors that just doesn't, keep angularly accelerating forever. And so you really can only reach one speed, and then there's some damping that the gravity blocks end up applying that make it slow down even more, to the point where sometimes if you hold down the key to turn, you'll basically you'll stop turning after a while. Luckily, for the same reason that it ends up stopping turning, it will also come to a slow without really turning your craft, through any sort of like internal resistance of the motor. So you could basically let off of it for a second and then let back on, and you'll continue turning. So it's not too bad. So we've looked at all three of these. Let's look at some practical examples. So I've got a couple different flying vehicles that I have set up, one of which I actually used during the test. So this behemoth, which was in an earlier video that I put out, is using just the piston-based torque generators. It's using a set of 4. It's using 2 at the front and 2 at the back to provide tilt control and turning control. So let's back up here, undo those changes, and we're going to go ahead and enter test mode and see how it flies. So like I said, these are really precise, this particular torque generator. I think it provides probably the cleanest steering, and as long as you hold down on it, it will generate torque. So it will continue to generate torque without interruption, and it really doesn't glitch out that often. So it's very smooth. Here's max turning in one direction, and then I can turn the other direction, and then I can tilt up, and I can tilt down quite nicely, to the point where I can actually flip over. The gravity blocks will keep me upright, but I mean, this provides for some super smooth flying. The problem being you have to have 4 of them for a full control set if you want tilt control and steering control. And it ends up being too heavy, as you see here, and you're slow to accelerate. And with how much damage the weapons deal to thin plates now due to the penetration mechanics, it's, in my opinion, not really worth it. But maybe once the wheels go away, the wheel glitch flyers, this will become a little more viable, although maybe not more viable than the other 2 vehicles that I'm going to show you. So there's one example, and then let's go to a flyer. Here we are. I think this is the one with the plasma. Yep. So this is a much more simple flyer that uses 2 of the tilt plate torque generators. And you can see here it's just flat plate pressing against this plate here. Really simple setup, not very heavily armored or anything. It's basically the bare minimum to hold it together. I've used the largest plates possible to reduce cost, so I can have 8 thrusters. So let's see how this one flies. And this one is using, so this does not have pitch control, it's just using the gravity blocks for altitude control. And then it's using 2 of the hinges for steering. And this is reasonably fast, and it's slender from the front, and it's got a reasonably thin side profile as well. And then of course the turning is pretty good. It's a little glitchy, like I said, with the hinges, but generally you can turn, well, there's one direction that goes, like I said, the hinges are, I'm using unopposed hinges, so they're more effective turning one direction than the other, as you can see. So let's fly here. But in general, it's pretty controllable. And there's another video of me, flying this one through buildings and being a little more precise with it. But it's generally pretty controllable. If I pilot through here, oh man, it's spinning out. Like you said, I gotta tap the controls instead of smashing on them. And I can probably actually flip one of the hinges so that I get effective turning both ways, since one's always in the effective direction and the other one's not. And maybe they'll oppose each other a little bit better. So there's that method of turning. And then let's go back to the good old tried and true. So this one probably will never get nerfed because I know Mark is a physics nerd, and this is, in reality what we use on spacecraft for turning. Good old-fashioned gyroscopes, or reaction retro rockets or whatever, but gyroscopes. They're in satellites, they're in some vehicles, and generally, so this is not a whole lot of mass. It's two plates. I've tried to use the medium material instead of the heavy material, and I've got two of them, so they can both turn both directions, and it's simple as it just connects right to the turn, or my left and right. No additional logic needed. One sends the motor one way, one sends the motor the other way. And then I've got, since it has to be in a flat configuration, I've basically turned the earlier build sideways, and I've got a side-mounted gun that's opposite the head of my pilot seat here, and then the gravity blocks are up there. So let's see how this one does. Oh, not that one. We want this one. And this does surprisingly well. I actually did not think that a normal gyroscope setup would work as well as it does. It still glitches out, similar to the hinges. It's just the motors being funny. But yeah, let's get into open space. But as you can see, not too bad. It's a reasonable. Now you see that kind of clang right there. That's the motors freaking out. And once again, if I hold down the key, it kind of saturates out. There's a max turning speed you hit, and then it kind of starts to fall off a little bit or glitch out like that. But not too bad overall. It's still plenty controllable. So if I try and fly through that base over there carefully. So just altitude control and gyroscopes. Oh, no, guess not. So I also don't have as many of the gravity blocks hooked up to the altitude control here because it ends up messing with the center of mass is wonky on this one. It's offset to the right. So there we go. 3 different methods of basically steering in air using 2 torque generators and just good old-fashioned gyroscopes. So, and this last one I'm pretty sure is here to stay. I doubt they're going to patch out, normal gyroscopes. And of course you can increase the mass on gyros to give them more of a range of wind-up, so a little smoother control. And then one more thing I wanted to cover. So here's just a normal, I'm making a PID controller, but let's ignore that. This is just the proportional hooked up, which basically means it takes the error from a sensor, and if it's positive, it basically, your plant model, in this case our motors here, get spun one way, and if it's negative, they get spun the other way. And then I've got, for different levels of power, since there's really only on or off for motors, I've got a pulse width modulator here that's basically just comparing. There's a clock that runs through, being incremented by one of the super fast short-circuited knots, and then if it's greater than a certain number, which is dictated by the proportional control, it's on or off. So you end up getting a portion of the time where it's off and a portion of the time where it's on, and then it returns, and it basically generates a square wave. And you can increase the resolution of it by increasing this number here, but then the problem is you run into, it takes longer for it to do a full cycle, and so you end up getting a lower frequency, and it ends up not being it's a little rougher, right? Like it won't generate pulses as quickly, and so it's like versus right? So and then there's just set up to recover this wheel if it stalls out. So this is just a inverted pendulum, and it wants to stay upright as the goal, right? So this is how you might, and you can do this simply with, you can basically run the control directly through if you're using one of the other types of torque generators I showed you that can take a variable force input. You don't have to do all this craziness unless you only have basically on or off for the hinge that you're trying to control. So let's see how this does. And this is just, the idea of a PID controller is you have, 1 just takes the error, multiplies it by some number, and feeds it right back into the thing that's meant to correct for that error. Integral would be the longer it's further away from the ideal position, the more of a correction it generates, right? And then the derivative is if it's moving too fast in either direction, there's a damping effect to prevent it from like overshooting. So here, we'll watch this go for a little while till it crashes, which it inevitably will just because of the way it's set up. And you can see it's unstable oscillations right now. It'll eventually mess up. In fact, I'm pretty sure it's going to right now. Oh, no, not quite. Oh. And like I said, you can get a reasonably, it's a wobbly, but it's a pretty good, doing a pretty good job of staying upright just with this setup. Now, ideally, it'd be standing nearly straight up and still if you have a properly tuned controller. And I'll make a whole video on it if I ever get this thing working, and then maybe I can simplify it to a point where, it's not unreasonably unaffordable. Okay, so here the error goes up because it's more than over 50% duty cycle, and then it basically stops the wheel, runs it the opposite direction to come back up, and then gives control back to the proportional controller. So maybe this will turn into something, but it's just another thing that you can use. Oh, there we go. And it picks itself back up. So this is just another thing that you can use gyros for. And, hopefully you can spend time on something and make it a lot smoother than this, right? Just based on, how your blocks are set up. You can do it without having to have all this mess. So, okay, there's, 3 different torque generators, 3 different practical applications of them in Fliers, and then a demonstration of basically a inverted pendulum with a little flywheel gyroscope to stay upright. Okay, hopefully this was helpful and gave you all some ideas on what you want to do with your crafts in the future. I'll be back with more later.